Welcome to the physics class, BSc, third semester, paper name Geometrical and Physical Optic, Electricity 1 and Basic Electronics. In this paper, Unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer. In this session 13, we learnt about Theory of Moving Coil Ballistic Galvanometer. So, now we see the diagram of the moving coil galvanometer. What are the contents they have? It has a supporting handle, scale and light source, mirror, phosphor, bronze ribbon, current source and fixed iron, horseshoe, permanent magnet. So this is the circuit diagram. And you can see the one torsional head and phosphor bronze strip and mirror, two pole pieces of magnet and coil, that is an fixed iron core, one of the spring we have and fixed end T2. See, so now we see the what are the principle this ballistic galvanometer works and what is the construction of the ballistic galvanometer, moving coil ballistic galvanometer. Now we can see principle. When a current is passed through a coil is suspended in a magnetic field, it experiences force in the direction of Fleming's left hand rule. So ballistic galvanometer, it can be works on the principle of Fleming's left hand rule. So now we see the moving coil galvanometer, how it can be constructed and working. So see this one. This is a moving coil galvanometer. It has a magnet and a scale and two pole pieces of the magnet. Inside one iron core. Iron core is moving with it. Iron core is covers with a circular copper wire is placed, and it can be how it can be working. The deflection of the galvanometer, it can be obtained. Please see this one. So now we see the current passed through a coil suspended in a magnetic field. It experiences force, how it can be. So the construction of the moving coil ballistic galvanometer, it consists of a rectangular coil. A thin copper wire is wound with a non-metallic frame of the ivory, and it is suspended means in a transfer, and it is suspended in a phosphor bronze wire between the poles of the powerful horseshoe magnet. A small circular mirror is attached with the suspension of the lower of the coil is connected to the hair string. It can be mirror will be connected. The upper end is suspension of the wire and lower end is spring is connected, T1 and the T2. So this is the mirror and upper end and the lower end. A cylindrical soft iron core is placed symmetrically inside of the coil between magnetic poles, which are also cylindrical in shape. This iron core concentrates magnetic field and helps in producing radial field. Working of the ballistic galvanometer is used to measure the electrical charge. The charge has to pass through a coil quickly possible and before coil starts moving. The ballistic galvanometer is used for measuring the electric charge. The charge has to pass through the coil is quickly possible to before the coil start moving. The coil thus gets impulsed and through is resisted. To achieve this, coil has a high moment of inertia is used so that period of oscillation is large. The oscillation of the coil is practically undamped. So what is the theory? Theory means In this, consider a rectangular coil having a n number of turns. We can see the simulation diagram. N number of turns of the uniform magnetic field of a magnetic induction B. Let L be the length of the coil and B is the breadth. Area of the coil is area of rectangle is length into breadth. When I be the current passing through the coil, the torque acting on that tau is equal to NIBA. The current passing through the short interval of time dt, the angular impulse produced in the coil is tau into dt, which is equals to NIBA into dt. The current passed through a t seconds, the total angular impulse is given to the coil is tau into dt, integral of 0 to t time limits tau into dt, which is equals to NBA is constant quantities and I is only vary with time with current, which is integral by from the limit 0 to t I into dt. So we will get NBA integration of I into dt becomes Q, that is total charge passing through the galvanometer coil. Let I be the moment of inertia of the coil about axis of the suspension and omega is its angular velocity. Then change in angular momentum of the coil is I omega is equals to NBAQ. Now we know kinetic energy of the moving system is of I omega square is used for twisting suspension of the wire through an angle theta. Let C be an restoring torque per twist, unit twist of the suspension of the wire, then work done in twisting the suspension wire by an angle theta. So therefore this equals to half I omega square is equals to half I omega square is equal to half C t square theta square. Therefore half and half gets cancelled. We will get I omega square, which is equal to C theta square. The period of oscillation of the coil is T is equals to 2 pi into square root of I by C. This can be squaring on both sides. We will get T square is equals to 4 pi square I by C. So I want I is equals to T square C dividing by 4 pi square. Multiplying equation 6 and 7, we get I omega square is equals to C square T square theta square dividing by 4 pi square. So next we will get I omega becomes NBAQ and I omega, which is equals to this one, we will change into the equation. We will get NBAQ is equals to CT theta dividing by 2 pi and Q is equals to, which is equals to Q is equals to, rearrange this equation, T dividing by 2 pi into C dividing by NBA into theta. This given relation is the change of the charge flowing and the ballistic through theta of the galvanometer. Therefore then T is a T by 2 pi and C by NBA becomes a constant term K. Therefore Q is equal to K into theta, where K is the ballistic reduction factor. Therefore Q is directly proportional to theta. This is the concept of moving coil ballistic galvanometer. Thank you for watching.